31 in the homework, it gives us some derivative information and asks us to put this kind of derivative puzzle together. So we have f prime is greater than 0 for x not equal to 2. And so that means that, that's the only information that's given about f prime. So that indicates to us that this is entirely increasing. Okay, so we know that this graph is always increasing through the entire region, except at x equals 2, and that means that it is, at that point, it's undefined. Okay, so it's increasing through those regions. The next part tells us about the concavity. So f prime, double prime of 2 is greater than 0 for x less than 2. So what's happening for values less than 2, we know it's concave up. Okay, so we know it's concave up, so it's going to be looking like that. And then for the x greater than 2, f double prime is less than 0, so it's concave down. Okay, so there's a change in concavity across that point, so at 2 there is an inflection point. It also tells us some limit information, some endpoint behavior. The endpoint behavior tells us that as x goes to positive infinity, there's a horizontal asymptote at 8, so there's going to be a horizontal asymptote at 8 going to the positive side. And when we take a look at the other part of that, it tells us that the endpoint behavior towards the negative, we have an asymptote, a horizontal asymptote at 0. And so as we put in the pointer, as I graph the inflection point here at x equals 2, y equals 5, maybe somewhere around here, we know that the graph of this is going to be entirely increasing. It's going to have an asymptote from 0 up to here. The slope is undefined at 2, and so we're going to have a vertical tangent at 2, and then it's going to switch concavity, and we're going to have a horizontal asymptote along y equals 8.